Hello everyone and welcome to all of you to our channel Schrodinger's Cat. So this is Devbrata here, and basically in your NEET and JEE physics in class 11 and 12 there are at most 18 topics, and in our previous lecture we had discussed the gravitation, and in the today's class we cover the lecture number 7, the properties of matter. So today we will cover the mechanical properties of solid and mechanical properties of fluid, elastic behavior and the material, the Hooke's law and elastic moduli, the stress strain curves elastic graph, potential energy and thermal stress, mechanical properties of fluid, the pressure, Pascal's law and Archimedes principle, fluids flow, viscosity and Bernoulli's principle, surface tension and capillary. And I just confess one thing, for your exam point of view, we just hear chapter summary in a nutshell and do problem coming in the NEET and JEE manner advanced previous year questions, very important. 5 and do your homework for 10 questions we just solve here, and after we just discuss the theory elaborately. And the total number of questions coming in the NEET exam, there are 2 or 3 questions, JEE main 3 or 4 questions, and the JEE advanced 3 questions are coming in these chapters, the properties of matter. So let's get started. First of all, the fluid mechanics. So I just draw a line for your clarifications. And so first of all, in the fluid mechanics, that the flow of the liquid. So first of all is the velocity gradient is defined as the velocity gradient is the del v del y. The velocity gradient is written as the del v del y, and the viscous force F is plus minus eta a del v del y, and the coefficient of the viscosity eta is equal to F by a del v del y. This is the velocity gradient. And next one be the Stokes law. If a spherical body of radius r moves at a speed v in the liquid of viscosity eta, that force acting on the body that depends on the r, v and the eta is written as the F equal to 6 pi eta r v. The Archimedes principle, next one, that the upward bounce force on a body inside liquid is equal to the weight of fluid displaced. This is the Archimedes principle, that Archimedes principle. Next one, that the terminal velocity of a solid sphere. Suppose let a sphere of density rho and the radius r freely falling on a liquid of a density sigma. So with velocity v, so upward force is 6 pi eta r v, the Stokes by the Stokes law, and the downward force is mg, that is equal to 4/3 pi r cube rho minus sigma into z. So we just equal to force and we get the terminal velocity Vt is equal to 2 by 9 r square rho minus sigma into z by eta. So one thing is that the terminal velocity is proportional to r square. Next one, the variation of pressure with depth, that the P is equal to Pa plus rho gh, where atmospheric pressure is Pa and rho be the density of the fluid. Next one, the manometer, that pressure of gas is equal to pressure of gas Pg is equal to P naught plus rho Gh, and the gauge pressure is equal to P naught minus P minus P naught, actual pressure minus the P naught. Next one, if Vj velocity and rho is density of liquid, then the volume flowing per second, that the Q is equal to AV, meter cube per second. Mass flowing per second, next one, the mass flowing per second is equal to AV rho, this is kg per second. Momentum mv is equal to AV square rho, this is momentum per second p by t, that is equal to Newton. And second one, the kinetic energy flowing per second, that the EK kinetic energy is equal to half mv square is equal to half rho a v square. This is volume and the velocity. This is equal to the half rho a v cube. This is in the watt. Next one, that principle of continuity. Suppose this is a pipe and the water flow through it. This is circular cross section of point P and the Q of the velocity, here the V1 and here this is V2. Here the surface area A1 and A2. So by the continuity equation, that the A1 V1 rho is equal to A2 V2 rho, that is AV is equal to constant. This is the equation of continuity. So next one, that the Bernoulli's theorem, that states that suppose this one, the figure drawn here is a section and another one, this is in height h1 and h2. Here this point may the cross section a1 a2, here the velocity v1 be the v2. So Bernoulli's theorem states that the p plus half rho v square plus rho gh equal to constant, and this is the expression for the Bernoulli's theorem, that the p1 plus h1 rho g plus half rho v1 square is equal to p2 plus h2 rho g plus half rho v2 square. This is the Bernoulli's theorem. Next one be the venturimeter, that I not draw here the figure, I just write here the formula, the V1 be the cross section of E2 root over 2gh divided by A1 square minus A2 square. This is for the venturimeter. Next one, that is the Torricelli's theorem, that states that Torricelli's theorem, this is basically a height of, this is h, and here liquid flow, this is the distance x and this height is h. So Torricelli's theorem states that the speed would become root 2gh. This is very important formula. And the maximum range, that x max is equal to root over 2 root over h by 2 into total height h minus h by 2. This is equal to h. Basically we just conclude here that root 2gh equal to h. This is the Tertiary's theorem, and next one the hydrostatics, that we just draw a line and the hydrostatics. So here that the relative density rho r is equal to density of substance by density of water at 4 degrees Celsius. Basically the weight of body in air WA divided by loss of weight of body in air, loss of weight, that the weight loss. This is the relative density. And another one, that the apparent weight W apparent is equal to actual weight, that is mg, minus force of, this is basically the bouncy force, that is v rho g, or equal to that the W is equal to mg into 1 minus rho by rho dash. This is important formula. Here the rho dash be the density of the solid and rho be the density of the liquid. Suppose a solid with density rho dash within the liquid whose density is rho. So this is the mg and this is the fb, bouncy force. Next one, specific gravity or the relative density. The relative density is basically, I just write here, the W apparent means the W and the W loss means the W minus W1. W and W1 be the weight of body in air and the liquid. Next one, the accelerated fluid. Accelerated fluid, that means suppose a system is in with a say cylindrical shape, within is a liquid whose density, the liquid density basically the rho, and the height is the h. So pressure between 2 points, that the PA is minus PB is equal to h rho z, that is g plus a. This is the upward acceleration. This is for the upward acceleration, and for the downward acceleration the pressure difference PA minus PB is equal to H0 G minus A. Next one, liquid accelerated in horizontal direction with A naught. I just draw here a figure for a better understanding, that this is a substance, here is in the liquid with the density, that is the rho, and here the point, this is A and the B. Suppose this is making an angle with theta. This is the acceleration A naught with horizontal, and this distance be the h1 and the h2. So here the pressure difference, that the PA minus PB is equal to d rho A naught. So the tan theta is equal to A naught by Z. This is another important topic. Tan theta is equal to A naught by Z. So last one, that the Reynolds number, that the N is equal to rho Vd divided by eta, where rho be the density of the liquid, V be the velocity of the liquid, d be the diameter of the tube, and eta be the coefficient of viscosity, and N, the Reynolds number, is the variation, that the N less than 2 into 10 to the power 3, 2000, this is the steady flow. Next one, within the range, that the 2 10 to the power 3, that's n, 3 10 to the power e. This is e means e to the power 10, e to the power 3. This is, I just write here that e to the power 3 means that 10 to the power 3. I just write the symbol with the Python script. So this is the unstable flow. Next one, that the n is greater than 3 e to the power 3, that means the 3 into 10 to the power 3, basically the 3000. This is for the turbulent flow. I just write the Python script e to the power 3 for your shortage of this line. That the next one, go ahead, that the elasticity. So elasticity, first one, that the equation, that the stress mean that the inertial force by cross sectional area, basically the F by A, and the strain is equal to L by capital L. This is the increased in length small l divided by initial length capital L. Next one, the Hooke's law. Hooke's law states that the moduli of elasticity E is equal to stress divided by strain. Young's modulus Y is defined as F by A divided by L by capital L. This is equal to F capital L divided by A small l. Bulk modulus of elasticity B is equal to that the minus P by V by capital V, or written as the minus V dP dV. This is important formula. Bulk modulus is equal to minus V dP dV. Next one, the compressibility. Compressibility is defined by beta, that is equal to the 1 by B. So inverse of the bulk modulus, that's the minus V by PV, that is written in the form minus 1 by V dV dP. Next one, modulus of rigidity. Modulus of rigidity is written as the shearing stress. Shearing stress means the F by A, and the shearing strain, that's be the theta, that F by A theta. Just put this value. So F divided by A by denominator X by H. This is the modulus of rigidity. So next one, the Poisson's ratio. Basically, suppose this is a figure with strain along this distance. So here this is the L, and the increase of L is L plus del L, and this is D, and increase D plus del D. So the Poisson's ratio sigma is written as that the del D divided by D with denominator del L by L. This is the Poisson's ratio. Next one, that the potential energy in a state string, the potential energy basically written as the energy with the unit volume. This is the energy density, energy by unit volume. This is equal to half Young modulus into strain square. This is Young modulus into strain whole square. This is equal to half Y A divided by L into L square. This is this potential energy in state string. I just write here. This is very important. Potential energy in a staged wire. Potential energy of a stressed wire is equal to U equal to half YA by capital L into small l square. Next one, the surface tension. The surface tension is defined capital T is F by L, and the work done by the force F when the wire AP is pulled out with a small distance del P, the work done here, the W is equal to F del X. Basically here that T into del A, and the surface tension here in this form would become T equal to W by del A. Next one, excess of pressure inside a liquid drop. Pressure excess in liquid drop, that the 2T divided by R. This is suppose bubble with radius R, and this is the excess pressure. Next one, excess of pressure inside a air bubble in a liquid. Here this is liquid within it, and the next one, this is within liquid, so is in the form that this is the rho, and here this is R, this is the del R, and here P excess would become 2T divided by R. And next one, excess of pressure inside a soap bubble. For a soap bubble, that would become the P is equal to 40 divided by R. Next one, very important, range of liquid in a capillary tube. Suppose this is a tube within a capillary here, so this is liquid, so here this distance is h, and this is a, I just draw one side that this is the tension P along with the angle theta, so this is the component of T cos theta, and here would be T sin theta, so another it would be here, so and this is also the theta, and this is the E, so you just do in your another side. So here the volume of water raised in tube, the volume V would be pi r square H plus R by 3, and the R be the R means the raised of water, that means in a capillary this is in water and this is the raised R, this is the R. And next one, the mass M would become that the pi r square H plus R by 3, basically the D equal to M by V. And the weight means the F equal to mg, that would become the pi r square H plus R by 3 into rho z. And next one, that the H height and the tension, so tension would become the RH rho z divided by 2 cos theta. And another important, that the height is most important, that the twice T cos theta divided by R rho z. And for water and clear glass contact, the angle is nearly equal to 0, so cos theta would nearly equals to 1, and the tension would become T, that the RH rho g by 2, RH rho g divided by 2. So we just cover the chapter summary in a nutshell of fluid mechanics and the fluid dynamics and the elasticity. So we just convert our lectures into the problem discussion session. First one is coming in the the JEE Main 2022 says that potential energy as a function of r is given by, and one thing is that this is very important questions, basically the coming in 2022 and 21. So basically the entrance questions is not repeating, but here this is coming twice. So this is very important, that the potential energy as a function of r is written as u equal to a by r to the power 10 minus b by r to the power 5. You have to find the equilibrium distance between two atoms. So equilibrium distance means first order derivative is equal to 0, that force is equal to 0. This is the condition of the equilibrium. So F means the minus du dr is equal to 0. So minus ddr of F means is written given a by r to the power 10 minus b by r to the power 5 is equal to 0. So next, or just do derivative here, that would become a by r to the power 11 into 10. Differentiate first time, that the 5b divided by r to the power 6 is equal to 0. So 1 by r to the power 6 is common here. So 10a divided by r to the power 5 minus 5b divided by 1 is equal to 0. So you just get here that 10a divided by r to the power 5 is equal to 5b. So you just get the value of r. This is the equilibrium distance, that the 2a divided by b whole to the power 1 by 5. So 2a divided by b whole to the power 1 by 5 would be a correct answer. So C would be a correct. Next, that the JEE Advance 2020 saying that an open-ended U-tube of uniform cross-sectional area contains water with density. Initially, the water level stands at 0.29 meter from the bottom of each area. Kerosene oil of density 800 kg per meter cube is added to the left arm until its length is become 0.1 meter. Right hand, its kerosene is fluiding in this right tube, and you have to find the ratio of H1 by H2. So one tube is kerosene is added, so increase of height, and you have to find the ratio of the H1 and H2 height. So we just apply here that, so first of all the total height, that the H1 plus H2, that is 0.29 into 2 side plus 0.1. So H1 plus H2, that would become 0.68. This is the equation number 1. And next one, the kerosene density rho K and the water density rho W. So we just write here that the P naught plus rho K GH 0.1 plus rho W G, H means H1 minus 0.1 minus rho W GH2, that is equal to P naught total pressure, that P equal to H rho G. H rho G, we just apply this formula. So just calculate, or rho K G 0.1 plus rho W G H1 minus rho W G 0.1, that is equal to rho W G H2. So we just put this value in this equation, that rho K is given 800 into 10 into 0.1 plus 1000 into 10 into H1 minus 1000 into 10 into 0.1, and right hand side the 1000 into 10 into H2. Just put this numerical value and we calculate here that h1 minus h2 is equal to 200, right hand side. So h1 minus h2 would become 0.22. This is the equation number 2, and from the equation 1 and the 2 we just get here the h1 value would become 0.35 and h2 would become 0.33. So you have to find the ratio of the h1 divided by h2. That would become h1 means 35 by 33. 35 by 33, that B would be a correct answer. Next, go ahead. That is coming NEET 2013. If the ratio of the diameters, length and the Young modulus of the steel and the copper wire shown in the figure is P, Q and S respectively, then corresponding ratio of increasing of the length would become what? So you have to find the increasing of length of the steel and the copper, that is the del L S divided by del L C. So that we just apply here the Young modulus, that is Young modulus OIH FL divided by A del L, that is written, one thing is that A equal to pi r square. So pi r means d by 2. So this is equal to the pi d square divided by 4. So here would become the F4 FL divided by pi d square del L. So or del L would become 4 FL divided by pi d square y. So now the ratio that the del L steel divided by del L copper, that the F steel by F copper and the L steel L copper and the D copper square, this is basically inversely, and here the Young modulus copper with the Young modulus steel, this is the inversely with these relations. Basically the del L, that is proportional to, with this equation number 1, proportional to F divided by d square y, FL divided by d square y. Just put this value. So here the F steel, that would become 5m total mass, 5m plus 2m mg, that the 7 mg, and the F copper, that the 5 mg. Just put this value, and the given the length of steel with the copper is Q, and the diameter steel with the ratio of the copper, that is the P, and the Young modulus steel with the copper is given as the S. Just put this value here. So del S del copper, that would become that 7 mg divided by 5 mg. Put this value, and this is the Q. So this is the 1 by P square, and this is the 1 by S. So this would become the 7Q divided by 5 P square S. 7Q divided by 5 P square S. B would be our correct answers. Go ahead, our next. That's coming in NEET 2022, recent type of questions. A spherical ball is dropped in a long column of a highly viscous liquid. The curve in the graph shown is in this. Which one of the represents the speed of ball as a function of time? So you have to find V as a function of time. This is the fx. You have to find this graph. So first graph, this is the straight line y equal to mx, and this is basically the x square equal to 4ay. This one, the x square equal to 4ay parabola, and this one is basically the fx is proportional to 1 by x, and another, this graph, this is basically the Gaussian type of graph, and we just think here the circle with a half, and we just write here the x square plus y square equal to a square. with a 1 by 4th, basically the 1/4 of the circle, this graph. So here one thing is that the ball is dropped in a viscous liquid. So you have to find the terminal velocity as a function of time. This is t origin and the vt. So terminal velocity graph increasing exponentially, and this is the saturate, that the constants. This point is the vt. So I think this graph would be our correct answers. This is this type of graph. This is for the x square equal to 4ay, the parabola. B would be our correct answers. This B. So I think A would be our correct answers. Just graph is given with a theoretical type of questions in NEET exam. Next one coming in JEE Main 2005. They is saying that water is filled in a cylindrical container to a height of 3 meter. The ratio of the cross-sectional area of the office and the breaker is 0.1. The square of the speed of the liquid continuing with this orifice is what? So this is the orifice, this section. So you have to find the v square of the speed. So orifice height 3 meter, and this is the orifice cross sectional area with the ratio 0.1 is given. So suppose this is the height of h, this section. So this is a point 1 and this is 2. Suppose water is falling in these directions, that's the v. So you just apply here the equation of continuity, and also here is in the height h, so you have to apply here the Bernoulli's theorem. So two theorem is applied here. First one is the equation of continuity and second one the Bernoulli's principles. So first of all, by the equation of continuity, that the AV is equal to constant. So A1 V1 is equal to A2 V2. This is the equation number 1. Next one, the Bernoulli's principle, that the P naught rho H plus half rho V square is equal to constant, that is equal to V1 square is equal to P naught plus, here this would be 0. Basically height is negligible. And next one, the half rho V square means V2 square. This is the equation number 2. So from equation 1 and the 2, we just get the value of the V2 square is equal to that the 2G's divided by 1 minus A2 square divided by A1 square. Just calculate the numeric value, you just put here, that is the G equal to 10, and this is the H that is given here. Basically the H is equal to root 2GH. The H basically equal to root 2GH. So here would become 2.475, and the 1 minus the cross sectional area is given 0.1, that A2 by A1 is 0.1. So 0.1 whole square, that would become the 50. Velocity square means meter per second, so meter square second to the power minus 2. So 50 would be our answers. A would be our correct answers. 50 meter squares per second square. So here we just conclude here with the 5 important questions coming in NEET JEE and advanced previous recent type questions. And for your better clarification and understanding and practice, I just usually give you for your home tasks, and you just pause this video and take a screenshot quickly of the 5 questions another. So I think you would just take a screenshot of this problem. So we now cover the 10 important questions from the fluid dynamics and the elasticity. So you just solve this problem and mail with this ID catschrodingers1935@gmail.com. So last but not the least, thank you very much. Stay well and happy. Have a good day.